Hi, welcome to this course. Hi, welcome to this microlearning course about the TCP IP protocols and how you're using them in your daily life. The objectives of this course is to try to explain to you what the TCP IP protocols are doing, because there are a lot of different protocols and they are doing different things for you, and you're actually using them every day when you're using your computers and accessing the internet. Not only computers, of course, all your other devices that are connected to the internet are using TCP IP. So TCP IP is kind of like the language of the internet. This is the common thing that we all using to be able to communicate with each other. If we had a device that didn't understand TCP IP, they will not be able to communicate over the internet. So this is to try to explain to you the different protocols and what they are doing. It's not a very technical explanation, it's more like the overview. The TCP IP protocol stack is like a stack of protocols, and they are divided into different layers. The whole idea of dividing it into layers is to get a more ordered structure of the different protocols, but also to try to isolate the functionality of different layers, which means also that we can change a protocol on one layer, and we only need to change the interface between the other layers. So we don't have to change all the protocols just because we change one. This is also one advantage of having a layered model. And we can explain what happened on each of these layers. And it's kind of like also to have like an index in a book. Things get easier to have an overview, and it's also easier to find something when you have the index. Same thing here. You have the different layers and you know where the different protocols belong in the different layers. So it's a layered model, and the TCP IP have 4 different layers. Starting from the top with the application layer is where you and your computer and your other devices are communicating with the protocol. That's called the application layer. Then we have the transport layer and the network layer and the network access layer. I'm going to try to start from the top because this is actually protocols that you might have seen, or at least the names of them. So let's start on the application layer. First of all, the one you probably have seen the name of is HTTP. It's the Hypertext Transfer Protocols. This is the protocol that used to transfer HTML objects to show them in your browser, so that you have web servers where everything is coded in HTML, and then you will be able to see the content in your browser. So this is like the protocol that carries these HTML documents and show them so that you can see, not only the code, but you can see actually how it looks in your browser. So HTTP is from you're getting things shown in your browser and also transferred from the web server to your browser. Then we have all the different names and numbers. And there is a protocol that will help you. It's called the DNS. It's called the domain name system. This is something that helps you so that you don't have to remember numbers. It's like a telephone book. The DNS is automatically there for you. So instead of putting in the telephone number, you can just put in the name of the person that you want to call. Same thing applies here on DNS, but here it's like where you put in the domain name. For instance, if you want to go to google.com, well, then the DNS will actually translate google.com to the IP address that is corresponding to google.com. Otherwise, if DNS were not available, then you had to put in the IP address like 172.207.17.67, for instance. And it would be very, very difficult for us to use the internet if we had to remember all the different IP addresses. So the DNS protocol will translate from names to numbers, and also the other way around. So this is very helpful. It's also the protocol that is made up so that we cannot use the same name. All names on the internet has to be unique, and it's actually divided into a hierarchy. We know the .com domains, we know the .dk domains, we know the .gov, the whatever. So all these domains are actually put into a hierarchy when we have two different types. We have the generic domains, which are the ones from the very beginning of the internet, the .com, .edu, .mil, .org, and all these other generic domains. And then we have the country domains for .dk, .uk, .no, and whatever countries. They all have their own domains. And we can also have like subdomains, for instance, easv.dk, and then we can have a subdomain underneath that again. So it's a hierarchy which makes us have more domains available to us. In the very top, we have the root domain, which is actually the dot in the end of a domain name. Then we have a lot of protocols here also that will help us send and receive mails. We have the SMTP protocol, which transfer mails, simple mail transfer protocol. Many mail programs today also use the SMTP to transfer mail to and from the mail server to your mail client. But otherwise, we have two other protocols that can do that for us. It's called the POP or POP3 or the IMAP protocol. These will take care of getting the information from the mail server up to your mail client. And then the SMTP protocol will send the information between different mail servers. So these are the ones that are taking care of your mails. We also have a protocol that will take care of file transfer. This is typically when it's huge files that you want to transfer. You're using something called the FTP protocol, file transfer protocol. You can also have, like if you click on a file in your browser, it will normally not be FTP. This is something, if you have really, really large files, you want to make sure that you get them correct. Then you will use a FTP. And you can put FTP and then the name address of your FTP server in your browser, and then you can actually transfer by using this protocol. You need, of course, to have a FTP server in the other end. Then we have move one layer down to the transport layer. Now the protocols they don't have specific application that they work for, but now they're working for the entire application layer. And here we will have we have two protocols. We have the TCP and we have the UDP. The TCP protocol is set up if you want to control everything. TCP will make sure that everything is transferred correctly. It will make sure that the receiver of the packets that you send is actually present before they start sending. And if something goes wrong, if something is missing, then TCP will make sure that it will be resent to you. So this is the protocol that controls everything. Sometimes it's not important that everything is done correctly. Then we are using the UDP protocol instead. And this protocol ignores everything. It just sends. And then whatever happened, it doesn't care. So the UDP protocol is something, for instance, if we want things to be faster. When we are streaming, for instance, we are normally using UDP. It doesn't really matter if one small packet is missing. We probably cannot see it or hear it anyway. So for us, it's more important that everything goes smooth and that we have the same speed of our communication at all times and don't want to resend or double check or do anything. So in that case, we are using the UDP protocol for that purpose. So UDP ignores everything, TCP controls everything. And the different application layer protocols work with either TCP or UDP. Then on the layer underneath the transport layer, we have the networking layer. This is where everything is transported from the correct address to the correct address. So the IP protocol, the internet protocol, is used to find the way. Find the way from one network to another network, or on the internet, finding its way to all the connected devices that are connected to the internet. So this is about how to find its way. Things are routed on the internet, which means that somehow these devices that read and understand the IP addresses, they're called routers, they will know when they look at an address where it is present. It's also here important that the same IP address is only used once on the internet. So we have these different companies that have different geographical areas that make sure that we are not using the same IP address on two different devices on the internet. So we have like the ARIN in North America, we have RIPENIC in Europe, we have AFRINIC in Africa, and so on. So these are organizations that just make sure that we don't use the same IP addresses. These IP addresses are not static, they are public IP addresses that are usable on the internet, and we are not able to use more than once. So they are unique. These IP addresses or the IP protocol is in two different versions. We have IP version 4 and IP version 6. IP version 4 is the old one. It's actually started already in the 1970s and were implemented and deployed in 1981. These addresses are 32-bit long, which means that it consists of 32 zeros and ones, because of course in the end all the devices on the internet are only understanding zeros and ones. And these IP addresses are, for instance, 192.168.1.1. That's the typical IP version 4 address. It's divided into 4 areas or 4 octets. It's actually a byte in each and 1 byte is 8-bit. So they are divided into 2 columns of 8 bits. So we have 4 of these altogether. So 4 bytes containing an IP version 4 address. When we calculate how many IP addresses we have in IP version 4, we have altogether a little bit more than 4 billion. And they are all used. We don't have more IP version 4 addresses. So the address space of IP version 4 is too small, which led us to develop an IP version 6 address instead. And here we have 128 bits long address, which is 128 zeros and ones. It's huge, large address. And when we see an IP version 6 address, we rewrite it into hexadecimal numbers to be able to see it. And it's like a large number of hexadecimal numbers. Here we have a huge number of IP addresses. I cannot even translate or say the word, the number. It's huge. It's like every grain of sand in Sahara could have their own IP version 6 address. So here we have hopefully enough IP addresses. The whole idea with IP addresses is that they have a meaning. They have like it's like they're divided into 2 parts, a networking part and a host part. The networking part is an address where all the devices on the same network have the same network address. And then the last part is the host part, which is different because, again, all IP addresses must be unique. So like here in this small setup here, we will see that all IP addresses here is starting with 192.168.1. This is like the network it belongs to. And then one of them is called 10, the next 11, and then 12. So these belong to the same network. On the other end, we will see that there is IP addresses called 192.168.10.1, 10.11, 10.10. So this is another network. And to be able to communicate between different networks, we have a router in between that can route traffic from one network to another network. But the whole idea of having IP addresses is that they will change from what network they are connected to. So when you're here at this school, you will get one IP address. When you go home, you will have another IP address because you are on different networks. There is, though, one address that does not change, and that is your MAC address, because the MAC address is like the social security number or the CPR number for your network interface card. It's like a burned-in address. It's an address that's already there and you cannot do anything about it. And on the last level, the lowest level, which is called the network access layer, this is where other protocols operate. It's, for instance, on local area networks. Like when you're here at our institution, you're connected to a local area network, or you're connected to a wireless local area network. And these protocols operate only within these small geographical area. That's why it's called a local area network, and it's something that we have bought here at the institution and we have set up, and we give our students the availability to connect to when they come here. At home, you buy a router, you buy something to set it up. So this is also a small local area network. And these protocols that works here are, for instance, something called Ethernet, or it's something called wireless LAN, or 802.11, different protocols. This is actually not a part of the TCP IP stack. This is something that's underneath and make sure that you can communicate and that you are connected. Yeah, and this is how, if you want to see a MAC address, then you can use ipconfig/all in your Windows computer and it will display your MAC address. Normally the MAC address cannot be changed. It's something that you already have. But when you communicate on a wireless LAN, for instance, or on an Ethernet LAN, well, then it's actually using your MAC address to send back and forth the information that you send and receive. And that was it. That was just a quick overview of the TCP IP protocol stack. Thank you.